Hi everyone, thanks for joining. We're just going to wait a couple more minutes, allow a couple more people to join, and then we'll start the webinar. Okay, hi everyone. My name is Telewa Lawson. Thank you very much for joining us today. Today we're going to have Miguel of CloudBees. He's going to speak a little bit about just what's happening. So, hi Miguel. Please introduce yourself, and I hope all of you have a nice presentation.
Hello, everybody. My name is Miguel Suarez, and I'm a customer success architect here at CloudBees. Today, I will be talking about CloudBees Core, specifically about the Operations Center and how its features can help us balance autonomy and control between teams that interact with your cluster. I'll be discussing a bit of functionality, but don't worry, as this webinar will be recorded for future reference. So first, we're going to talk about CloudBees Core users, their responsibilities, and how CloudBees Operations Center can help achieve their goals. Second, we will briefly discuss CloudBees Core cluster architecture and the role of the Operations Center. We will also talk about the differences there are between CloudBees Core in modern and traditional. After that, we will explain different CloudBees master types, team masters, client masters, and managed masters, as they are part of your cluster deployment. The last part is a demo of how to get started using the Operations Center with an example use case where we can set up authentication, authorization, a managed master, and a team master. We will also create a cluster operation for them and set up a share agent. So first, why do we want to talk about autonomy and control in your cluster? And what does it have to do with CloudBees Core users? CloudBees Core is used in different ways by different teams with different responsibilities, developers, admins, testers, managers that can be involved with CloudBees Core on a daily basis, as all of them are responsible to build and release code to satisfy business demands. These teams also interact with each other, which naturally become a responsibility and accountability coordination. What we want in this webinar is talk about how technology, in this case the Operations Center, can minimize the friction between teams and simplify their tasks. Let's talk about some of the different team compositions and interactions between them and with CloudBees Core as well. These are not all of them. I will talk about 3 of them, but this is what I, as talk to multiple customers, see on a regular basis. First, I named this self-service. We have this model where developers are looking for fast CI/CD. These teams are feature release, bug fix focused with little contact with CloudBees Core. These development teams want to be able to build and deploy applications following what other teams are doing, and they're usually provided Jenkins files that they need to include in their repo, or their Jenkins files are controlled by another team using features like custom marker files. Then on the other side, we have shared services teams, which are in charge of all the CI/CD infrastructure and process. They create, maintain, and support the CI/CD infrastructure for different teams. They have to do the heavy lifting, creating, maintaining the infrastructure and pipelines or jobs. Pretty much they are in charge of everything that the other team has to rely on. Another common example that we see is where there is a shared services team in charge of providing the CI/CD to cross-functional teams. Shared services team, in this case, they create and release the infrastructure with limited functionality and make sure that it's compliant with security. They provide a wide variety of plugins that they trust, set authentication, provide best practices as guidance, enforce upgrade timelines, but at the end, they let other cross-functional teams to make the decisions on what they want to do. These other teams, which are cross-functional, composed by testers, developers, and business analysts, they share the responsibility of maintaining or operating the master. They use these plugins that were offered to them at their will, connect to other systems like source control management, or set up their Nexus repository for their binaries. And last but not least, another common pattern for customers that are very interested in implementing DevOps is exactly that. They have teams that create, release, and maintain infrastructure and applications, including CI/CD. So they not only release new features, they also are in charge of taking their own decisions and seeing what fits best for them. Basically, these teams contain a shared services team, developer team, sysadmin, everything in one small team that is self-sufficient. In conclusion, you might be one of these teams, or maybe you have your own different organization that works best for you, or maybe a combination of all of them. No organization is the same, and it's not easy to prescribe how you should be organized. It depends not only on the technology that you have, but also on the people and the processes. Now I want to talk about planning and thinking ahead, because you can be in a shared services team, or maybe the person in charge of core in a cross-functional team, or a developer trying to add new functionality, or you just want to understand how your code gets to production. You may be the first or the last, but these are a few things that you want to keep in mind. First, you want to avoid master sprawls. These occur when different teams create their own master and there is no coordination between them. There is no reusability and or visibility for configurations between teams, which can lead to poor utilization of resources and lots of time wasted repeating processes. Also, you can try to avoid Jenkins styles or monolith masters, which are single installations containing a large number of projects and teams, leading to poor performance as well as dependencies and administration nightmares. A single team can bring down the entire infrastructure, affecting other teams when these instances are shared and poorly managed. Also, make sure that you expand knowledge, avoid repetition of work for common processes. If there are other teams that are looking at your solution, be sure that what you are already created is shareable. Be compliant with company policies to protect builds, resources, sensitive information such as credentials. Make sure that your platform is being used by authenticated and authorized individuals against company-wide systems like LDAP or AD, and follow established processes. Then automate and monitor your CI/CD infrastructure to prevent loss of work, and make sure your infrastructure is ready to handle resource-intensive jobs or be prepared for peak times. You should also monitor pipelines to see how much time is taken to deliver new features. Be prepared to scale and recover, because when you have new teams, you want to make sure that those teams don't have to reinvent everything that you've done. And if anything goes wrong, you need to make sure that you can recover fast. And last but not least, be efficient with your resources and distribute them across your infrastructure. Don't forget that you can be in any team, but don't forget that the common denominator between them is to get applications and new features to production in a predictable, auditable, monitored, and scalable CI/CD infrastructure. So we talk about how you can be different teams and some advice for future planning. Now let's talk about technology and how it can help you. Let's talk about the Operations Center. The Operations Center will not solve all your problems maybe, but it's definitely helpful to know what it can offer to achieve these goals. So I'm gonna get out of here, and I wanna show you real quick how the dashboard of the Operations Center looks if you have not seen it before. The dashboard looks pretty much as any other master, like any team master, managed master, but the difference is that you can have your masters connected to it. In this case, I have a team and a managed master that I will explain later. And another difference that is pretty noticeable is that you can create other objects from here, like cluster operations that we will explore later, share agents, share clouds. All right. So before starting mentioning features available, I want to make sure that we all have an understanding that CloudBees Core is offering traditional and modern platforms. The main difference is that CloudBees Core in modern platforms is deploying Kubernetes, which extends the functionality of CloudBees Cores in traditional by adding functionality out of the box from Kubernetes, like self-healing masters, which run as containers, and ephemeral agents based on container images. The Operations Center is available in both traditional and modern platforms, but the functionality changes depending where you deploy it. Going back to what we mentioned, that we should create more masters to avoid Jenkins times and also be careful with masters pros. How can we do that? We need a way to connect all the masters to a centralized system to manage them. The Operations Center provides a dashboard, as I showed before, that shows client masters, managed masters, and our teams, all under one page and one URL that can be resolved. If you're using Core Modern, you can avoid Jenkins times by spinning more masters on demand from the Operations Center in a predictable way using managed masters and team masters, which we will discuss later. We also mentioned that you have to be compliant with company policies. From the Operations Center, you can manage plugins. And when I say plugins, I know that that's complicated for a lot of the customers that we have. That's why we strongly recommend to use CAP, the CloudBees Assurance Program, in every master. That's not centralizing the Operations Center. You can put it in all your masters and Operations Center, and I will talk about that in a future video. Now, from the Operations Center, what you can do is you can extend CAP using catalogs to pin different versions or plugins not yet in CAP. Or if you have your own plugins, you can also extend CAP with catalogs. Also, another feature related to plugins is that you can select team recipes, what you have on your right. These team recipes are enable team masters to be provisioned with plugins out of the box. You can mix a plugin, a catalog with a catalog for the version and a recipe for which plugins do you want. The one that I have here on the right screenshot, it's the one that comes with the installation. There are usually two that comes with the installation, a basic and a Java. And also I wanted to talk a little bit about cluster operations again, because it allows you to schedule and automate operations across your cluster so that it's easier to prevent loss of work with backups and upgrade masters from one place. Now that you know what it can do at a high level, let's talk a bit about specific features. I consider the following list something that you definitely need to take a look at when you start architecting your cluster, as it is better to have a plan for this before you start creating pipelines. These features have to do with master management from the Operations Center. So first, I'm going to talk about the security realm, which is authentication. You can use LDAP, Active Directory, SAML for systems like Okta One Login that allows to reuse usernames and password across your organization. But if you don't have that system ready, you can also use Jenkins' own user database, like it's on that screenshot, or a mock security realm that it will use users and groups as if they came from an external system like AD. Actually, we're going to use that in the demo. Then one feature that is very powerful in Core is RBAC. Once you have users and groups from an external system, then you can use granular roles to allow access to specific resources like masters and folders. Now that you have your users and you know what they can control, what you need to make a decision is about how do you want to connect these masters with the operation center? Single sign-on. Do you want all these masters to use the security and RBAC? Do you want some masters, or do you want the masters just using the authorization or authentication? Sorry. We already talked about cluster operations. It's just reinforcing that idea on how you can manage masters from here, as well as plugin management, catalogs, and theme recipes. So now let's talk about how you can distribute your workloads from the operation center. The following is a good list to consider for your architecture. The list of features that Core has is quite extensive, but I'll try to give a brief description of what these features are. First, share agents and share clouds. You can use them to optimize the use of resources to be utilized by different masters using labels. I'm going to do an example of that when I will do a share agent. Share clouds allow you to add resources, but to a pool when needed, and share agents allow you to use specific agents using SSH or GenLP. You also have share configurations and Chrome masters to avoid repeated configuration for common functionality between masters like emails or tool installation for things like Maven or Git. And then folders at the operation center level let you have a better organization of different resources. You can specify which children object type the folders can contain. For example, on the right, I can create, I can create different folders where I can just put certain objects that I want. That will help a lot with RBAC and make sure that only some users can access these resources. Another one of the newest features is cross-master events or cross-team collaboration that let you publish events and trigger jobs in other masters to connect different teams. So you can divide them in consumers and publish masters. They can pass a JSON payload, and then the consumers can decide if they want to do something with that payload or not. Also, we have a way using that same method to trigger pipelines from external webhooks such as Docker Hub, Nexus, or GitHub. Now, you can also move, copy, and promote jobs, for example, from master to master. A good use case is we recommend having test and production masters to make sure that changes for your cluster do not impact your day-to-day work. When you connect your masters to the operation center, you can test and later move, copy, or promote jobs. So where is the operation center in the CloudBees Core architecture? In this high-level architecture diagram, we can see how the operation center is in the middle of CloudBees Core, connecting plugins, external authentication systems, and agents to your masters. One thing to take in consideration is that it can be architected for high availability purposes in that traditional deployment. And also another important fact is that users won't lose access to the masters if the operation center goes down. But you need to make sure that these masters that are connected use the same plugin for authentication like AD and are in the same version as well. In the diagram, we can also see that besides share agents and share clouds, you can have agents for each master as usual, as they can also be ephemeral using Kubernetes or static using VMs or bare metal. So now let's talk about CloudBees Core masters. Masters are one of the most important building blocks of your infrastructure. Let's discuss how the operation center can manage and provision masters, the different masters that we offer, and their relationship with the operation center. There are 3 types of different masters that you can connect to the operation center. First, the managed masters, which are provisioned from the operation center using a Docker image provided by CloudBees. If your Kubernetes cluster does not have access to the public registry, then you can also configure a pull secret to be able to pull from your own private registry. You can define things like memory disk, namespace, also things offering traditional like plugin catalogs, shared configurations. Managed masters take advantage of Kubernetes health checks to be able to restart automatically. These masters are by default provisioned in the same namespace as the operation center, but they can also be provisioned in other namespace if you give the necessary permissions to the service accounts. Then we have team masters, which are what we can say turnkey managed masters, which they are based on managed masters, but they have simplified authorization for self-organized teams. And they come by default with 3 simplified roles: team admin, team member, and team guest. But you can also add new roles if you need it using the CLI. The team master admin can configure credentials, folders, and tools at the master level. Team members can read, write, and execute pipelines, and then guests can only browse through the master, but do not change anything. These are the types of masters that you can create using recipes and catalogs from DOC. And we also recommend these masters as they are ready to onboard new teams as they come to the infrastructure. On the right, you can see that it's a new improved UI where you can name a team. You can also add people in the same interface, and you can add users or groups. And then at the bottom is where you select what kind of recipe do you want. You can add more recipes, but as I said before, it comes with 2 basic and Java. So client masters are what are commonly linked to core on traditional platforms, but they are also available for modern platforms. The difference is that these masters are not created like they are in modern from the operation center, but they can be attached. If you see on the right, there are 2 ways to connect these masters to the operation center. You can put the URL of it in the operation center, or you can push the configuration to it. These masters also have catalogs and shared configurations. This is important because sometimes we have customers that go from traditional to modern, but they want to connect these masters to an operation center in Kubernetes. So that's possible too. You just need to make sure that your operation center is reachable from the outside or from outside of the cluster. All right, so I'm gonna do a demo. And basically the demo is what I would consider you should take a look right after installing. So let me show you first my cluster or how it's at this point, and then I will show what I did to get it to this point. So here I already have a team master, a managed master that I'll show how to do. And I also created cluster operations and share agents. I also have configured a mock security realm with to kind of follow what you will do in AD or LDAP. I've also set authorization using role-based metrics and single sign-on, which allows you to connect using the same credentials to your masters. All right. So this demo or this cluster that I have set up, I used the marketplace on Google Cloud Platform, specifically using GKE, Google Kubernetes Engine. We are in Microsoft AKS, and as well as we just released an AWS Quick Start using EKS and EC2 Spot instances. We also support Pivotal and OpenShift. So if you haven't used CloudBees Core on modern platforms, you can take a look at it. It is bring your own license, or if you don't have a license, you can use a trial license. If you have never used any of these public cloud providers, usually they give you a free credit, and it is very easy to set up from the marketplaces, as the CloudBees Core will set up your cluster, giving nodes, and it's ready to go. The purpose of the demo is to start setting up my core cluster for two teams, Team A and Team B. I'll be using initial roles, enabling authentication, creating a backup operation, and creating a share agent. So on the left-hand side, I have Team A, which has, these are how the external roles are. Admin A1, which belongs to a group called, external admins. Then we have admin B1 and developer B1 for Team B, and Team C, which I won't give a master. It's just so we can see that not everybody can see all the things. So a few things to consider when I talk about roles and masters. Team master roles in our case for Team A are different than the roles in the Operations Center for managed masters. So Team A will have its own way to use RBACs that will be shown later. On the left of this diagram, we have the external users and the groups. And on the right is where we're going to set up in CloudBees Core. So there are three levels of RBAC that we have to do in this implementation, as we will have the Operations Center level, then we'll create a folder to have the managed masters, and then the master itself. That's why you see here three groups, browsers master group, and then master admins, browsers master group, master B developers. And then for developers, from the C team, you have browsers, masters, and none, because they won't be able to access. This is definitely not the easiest way to do RBAC, but it can show how granular it can be. You can use this where you pretty much tell everybody what they can see, or the other way that some people do is you can just have authenticated users, and then to each individual resource, you will give them access. All right, so I have recorded a few videos on how I got my cluster. I think some of them are not that clear from what I've been told, but I will upload these to YouTube or share these in case you cannot see them. So first we need to add the users from the external system. I'm going to log in as admin, which is a user that you always set up in the wizard. And then we're going to go to start setting up the security role. So the MUX security realm that is going to be selected here, on the first column, it has users, and on the second column, it will have groups. this is a way again to test if your AD is not ready and you want to see how you can do RBAC. This is a good way to test it. But then you have to make sure that you can little by little or doing. I recommend here in this security not to make too many changes at a time. Do one change for security or one change for authorization so you don't get logged out or run into some other problems. We're gonna leave the authorization with logins. Users can't do anything for now. We want to try to do these changes one by one. Now we're gonna save and log out, and we're gonna try to use one of the users that we imported. So the first user, which is going to be a cluster admin, is called cluster admin. And for this mock security realm, the password is the same user. So now it was able to log in with that user. And then the next step that we want to do is set up the role-based matrix authorization strategy with the typical initial setup, which will give you 3 default roles: administer, develop, and browse. Once you save, you will see 2 new objects on your left, which are the groups and the roles. And you can take a look at the roles by clicking there in roles and manage. So here you will see the 3 new roles that have been added by default. And I recommend this as a good start if you're not sure on how to set up your RBAC, then you can start using this. Then by default, since I'm cluster admin and I'm the one that enabled this, it's gonna be automatically adding me to administrators so I don't get locked out. And then I can also explore in who am I, and this will tell you which group you have, which role you have, and if you are linked to any external groups. In this case, cluster admins. So here's a quick test just to see that the other roles are not available to authenticate. So you saw admin A1 cannot see anything, admin B1 cannot see anything at the operations center level. All right, now I'm gonna create a manage master for team B and set up RBAC for it. So first, it was only one user, but what we want to do is actually add the external group for that user to be able to have cluster admins. So here, oops, you can add the external group, and you will see how it says when you hover over it, it says that it's external group. So when you set up RBAC, you also want to start from the higher level. In this case, we're starting from the operations center. And then you don't want to propagate over to smaller resources until you get there. This will make more sense as I go with the demo. So now, as I said before, we're going to create a manage master folder where you can have all your managed masters. And one thing that it's good practice is to select which kind of objects those folders have. All right, before creating a master, I also wanted to show where is those master images lived. So if you go to manage Jenkins and you look for Docker images, this is where the images will show. Now we're going to create a new master for team B. So before you create it, you can see all the options that you have. This again is going to be provisioned by Kubernetes. So you have your image. You can select how much disk do you need, which domain, so where it's going to reside, master memory, JVM commands or parameters, and then in the bottom you can see health check, which will enable Kubernetes to restart if they fail. Other important things to take a look here is image pool secrets, in case you have a private registry. And then you can also specify things that are common to other master shell plugin catalogs. You can click on log and it will do a follow on the log of Kubernetes. So there you can see if the pod started or not. All right, well that creates, let's go and start setting up RBAC. So we have 3 groups that were created at the operations center level: administrator, developers, browsers. We already said that you're gonna have cluster admins with privilege that propagate across all your entire cluster. Now, what we wanna do is add the browsers, which are all the groups that you wanna import from the external system. I'm gonna speed up a little bit here, but basically what I'm doing is I'm adding all the external groups. So admins for A, admins for B, devs for B, devs for C. Another thing that I wanna make sure is that they can only browse at this level, because you wanna keep it in the same level until you reach the actual resource that you want to be authorized for. So we're at the operations center right now. Then the next level is give permission at the folder level. So you can see how this tree is starting to populate. So this is the top part with the external groups, and now we are in the folder called Manage Masters. Now for Manage Masters, what we want to add, first we need to create an internal group so we can add external groups, because there are two types of groups. Again, you want to make sure that the browse does not propagate, because what you want to protect right now, it's your master that is going to be inside this folder. So you set up the role, and now you're going to add the users or the groups that are going to have access to manage masters. So you don't want to add team A here, because team A is going to have a team master. So you will add the B admins, the B devs, and the C devs. All right, so by now your master should be ready. And here, so let me go back. Here I clicked on the master because I knew it was ready because of the dashboard. But usually when you spin up a new master, it will tell you it will ask you if you could if you want to install the suggested plugins, and it's always recommended to install the suggested plugins. The only reason that you don't see that here is because I've spinned the same master with the same name, and it has the same disk or the same persistent volume in Kubernetes. So it already knows which plugins it has. So one thing that we want to do is set up the roles for who's going to have access to this specific managed master, which is master B. So only the members that are B admins or B developers. First, we create an internal group called master B admins. And here we map it to the external group called external B admins. There is a lot, what you want to have as a best practice is a one-to-one relationship. You don't want to have a administrator of your cluster given a special permissions for some different groups that do not map one-to-one. Now we're going to create a group for master BDEVs. And we're going to map it to the external group. So here you can start seeing how this tree stops forming. So everybody at the operation center is part of browser. Then the managed master only has B admins, B devs, and C devs because team A would not have a managed master. And then for your actual master, you're going to have admins and devs with two different roles. One other thing that you have to make sure is that, as I mentioned before, if you are using a plugin to authenticate, you want to make sure that it's installed in that master so the relationship between the operation center and the master works. So here I'm going to install the mock security ROM just to make sure that if my operation center goes down, I can still log in. So I'm just going to skip this part. Basically, you just make sure that it restarts after installing. And then you just need to wait until it comes back up. All right, as I only have 5 more minutes, I want to show how we can validate, or how we validated that only some users have access to this master. I don't think I will be able to get to the team master, but I will make sure that these other videos are available for you to follow this. So you can sign in as a cluster admin, and as a cluster admin, you have operation center access. You have access to the master. If you go back to the operation center, you see on your left that you can manage Jenkins. You can manage the operation center, I'm sorry. Now let's try to log in with admin A1. Admin A1 cannot see anything in the operation center or any master because we didn't give permission for that folder or the master itself. Then we can log in with the admin B1, and you can see in the operation center, you can see the master, but you cannot see on the left manage Jenkins, which will let you manage the operation center. And since you're an admin for this master, you can see on your left that you can manage it. So let's try developer B1, which don't have access to the operation center. So here on the left, you see that it doesn't. And it also does not have access to or manage access for this master. Now we can try developer C, which wasn't given any access to the masters or the operation center, so it cannot see anything. And then we can try a different user that was not important for the external administration, and it will give you an error. All right, I have 3 questions. I can probably go and do the team master really quick and answer those questions. So we mentioned that we were going to give a team master to team A. And again, this does not use what we've been doing with role-based access. This is a different system, so you have to treat them as different masters. So let's log in with admin A1, and we have not given any privileges yet, so you cannot even manage your own. You have to be logged in as a cluster admin, provide a team master, and then start adding users. So now we can create a team. In this case, we're going to call team A. We're going to give it any icon. And here is where you can add users that are different. So we had an external group called team external team A, and we can put it here and it will map to admin. So there are only 3 roles as you saw by default. You select your recipe, which can be Java or Basic, and that has to do again with plugins that you want to. And the good thing about team masters is that you can modify recipes or members through the CLI using JSON. So what's happening in the background when you spin up a team master? What it is actually a managed master, but again, it has the features that we saw, but in the background, what it's spinning is the default values for the managed master. So the default Docker image was this one from GCR, which maps to a version of our CloudBees Core, and then the default values for disk, CPU, memory, and ratio. You can see the log. And that's all. That's how you create a team master. One thing that I want to mention is since I use, so we have three instances. We have the operation center, we have a managed master and a team master. When I use the marketplace for Core in Google, I had to enable auto scale as it only deploys 3 nodes and we needed 4 nodes. All right, I have 8 minutes. So I will take some of the questions, and I have 2 more videos for 2 short videos about how to use cluster operations that I will share, as well as how to create a shared agent when I do an example of how 2 different masters can move and use a single agent using labels. There are also a few recommendations before I finish. Some of the things that I've done are just for testing, like Mock Security Realm is just for test. Use it as a way to test your Active Directory. Always decide your master strategy, and if you're really looking for a granular way of using RBAC, go with role-based matrix. Otherwise, try to pick teams. As you've seen, it's very easy to start installing masters. Remember to install authentication plugins in the operation center and masters and make sure they're the same version. Oops. The other 2 are related to the other 2 videos where you don't want to create backups in local directories, and you want to make sure that you check the host key when you connect to a shared agent. All right, so I have 7 minutes, and I want to see some of the questions. What is the explicit feature differences between modern and traditional CB core? So team masters, so everything that you gain from Kubernetes, team masters, recipes, managed masters. Traditional, it's only for client masters. Can we start with CloudBees Core on traditional because you're still adopting Kubernetes and then later migrate to core? What are the efforts in migration? We can definitely help you out with that. You're not the first one. It depends on how much you have and in how many masters, but we can definitely set up a plan to start migrating little by little certain pipelines, or also for freestyle to pipelines in Kubernetes or in modern. Also asking for documentation. I can follow up with that. And asking about team masters, if it exists in traditional and modern, and the answer is no, only in modern. Also, when should I use ephemeral versus static agents? This is something that I want to talk about. If your load is resource intensive and it take a long time, definitely take a look at static agents. But if you are building or testing code, definitely look at ephemeral agents. And that's all I have.
Okay. Well, thank you so much, Miguel, for that. That was a really good talk. Thank you, everyone, for joining us today. I really appreciate the time that you guys took out of your day to listen to us. If you do have any further questions, please, you can feel free to reach us, and we can try and answer as many things as you guys require. These presentation will be sent out later. We'll work on all of that. But thank you for everything, guys. I hope all of you have a wonderful day, and hope we'll all speak soon. Thank you. Thanks again, Miguel.
Yep, thanks.